Okay, so obviously, operations that you might want to do on a calculator, and again, I'm still trying to kind of think about Python as being an awesome calculator. One of the things you might want to do with a calculator is to compute the square root of a number. So, for example, maybe let's try this. What is the square root of a number? Well, it's just raising it to the power of 1/2, and there we go. Okay, so something like that would be one way to do this. And of course, if we wanted to compute the third root, let's just do the third root of a number that we want. We could do something like this, and we get 3. And if we just wanted, what if we did the 0.3 root, which is kind of almost the third root, we get something close. Okay, so this is one way that we could compute, roots using just the operations that we learned before. Okay. But let's say we want to use square root. There's reasons we want to use things like square root instead of raising something to the power of 1/2. So Python like the version of the thing that we have right now comes with a bunch of different packages, and then there's going to be other packages that we can add on. One of those packages is called math. And what is a package? A package is essentially a set of different functions. So a package is a whole bunch of different functions that we can use. I haven't told you what a function is yet. We will see it by example here, but it's like a whole bunch of different, imagine it again in the context of a calculator. You kind of have your calculator like this, and a package is something that you can plug in here, and you have all of these buttons over here that you can now use. Obviously, this is a graphing calculator and square roots here somewhere, but that's one way that you can think about a package. You have your calculator here, you plug in a cord here or there or wherever it'll be, and that'll give you, you have a whole bunch of buttons over here that you can now use. Okay, so the way that we, plug in, obviously we're not plugging anything into the computer, but the way that we plug something in is by using an import statement. So I'm going to say import math. So there's this package called Python. This is when we say import math, that's like plugging it in. So we have import math. We've now plugged in our math calculator to this calculator. Okay, not that this isn't a math calculator, but just go with me. Okay, so now I'm going to do Shift Enter, and now all of the functions in math we have access to. So if I want to use square root, I'm going to do math dot square root of 4, and when I run this, I'm going to get 2. Math dot square root of -4. Okay, so the error here is that we're doing the square root of a negative number. We will see later on how other packages that will be able to handle this for us. Okay, so this is how we can do square roots. So again, we have to do math.square root. Square root is the name of the function. In other words, it's like the name of the button over here. And when we say math.square root, it means we're pressing the button over here. So maybe I plug in, later on we're going to see maybe we will have multiple input statements. So maybe I plugged in one set of buttons over here and one set of buttons over here. And let's say there's a button over here called square root and a button over here called square root. I have to tell it which set of buttons I want to use. And by doing math.square root, it's saying, okay, go to this set of buttons, or go look into this package called math and find the function called square root, and then compute it here. So if you do math.square root of 4, it computes 2.0. It computes the square root of 4. Okay. Okay, sorry, somebody came in my office just then. Okay, so again, math is this whole set of package with this whole set of functions. If we want to access a function, we do math.square root, and that's the name of the function. Okay, so now I've said function multiple times. What is a function? Well, a function is maybe exactly what you would expect. A function takes in different inputs, and it gives out an output. It takes in inputs, gives an output. So this square root function, it takes in one input, that is the number 4, and it gives out one output, that is the number 2.0. Okay, so let's look at another function here. So let's say we want to do sine. Math.sine, okay, let's think about this. Let's compute the sine of an angle we know. Let's compute the sine of a 90-degree angle. And now let's ask the question, do we think it's going to be radians or degrees? So I'm going to do math.sine of 90. Now, if it's degrees we're supposed to put in here, I should get 1. If it's radians, I'm not going to get 1. So I'm going to run this, Okay, so I don't get 1, so it's probably radians that we need to put in here. I mean, it is, I know that. I'm just trying to act like we're talking about this together. Okay, so let's just think about the most obvious thing to type in here. So if I want to do pi over 2 radians, that is 90 degrees, let's just do pi over 2 and see if this works. Okay, so now pi is not defined. So another thing that is included in this package called math is a list of constants. So I can do math.pi. So math.pi is the pi that we're familiar with, and when you run it, you get 1.0. So if I just do math.pi and I run it, I get 3.14. Okay, so again, if we think about the analogy of having the calculator and plugging in this set of math functionality, it's like there's just a button over here that says pi, and if I press pi, it just means this 3.14. Again, back in the real world and not the analogy, there's just a constant in this set of packages called pi, and we do math.pi to get the value here. There's also an e, and we can get e there as well. Okay, so let's try another one. Okay, let's think about natural log. So let's try to find a natural log function. Math.natural log of math.e. Okay, so if I do this, I should get 1. If everything works out the way that I think it should be, if ln does mean natural log, everything should work out the way that if ln means natural log, if within the math package ln means there's a function called ln and it means the natural log function, when I run this, I should get 1. Let's see what happens. Okay, so ln. Okay, so the next obvious choice might be log. Now, maybe you're used to log being base 10 log, maybe you're used to it being the base e log, maybe you're used to log being the base 2 log. Let's run it and see what we get here. Okay, 1.0. Okay, so now what this tells us is that the log function in the math package is the natural log function. So for example, if I do 10, I'm not going to get 1. Okay, so the base of, so if you do log in the math package, you're going to get the natural log. Now, sometimes I can't remember, there's some packages where something like this might work. I can't remember it right now, so this might not work at all. Okay, so log 10 gives us the base 10 log. Maybe base 2 log will get this. Okay, so these are different log functions. So one very good thing about this is all of the functions have very descriptive names. I'd forgotten that log 10 and log 2 were functions, but I thought they might have been because I kind of remembered it from other things. Okay, but let me just let's just go back and let's say we didn't know that log base 2 was a function or log base 10 was a function. Obviously, we could use a change of base formula, but let's say we don't want to do that. Let's say we want something a little more simple like this, but we just don't know something like that exists. I mean, I'm going to show you how I do. I mean, there's hopefully, I don't have to tell you about Google searches, but this is how I would do it. Python log base 10. Okay, so log 10 function, and then it comes right up here. I mean, there's many different ways to look, many different link options there, but we see right away here, import math, print math.log10 of a. Okay, so now this is going to be fun. Now, what's not going to be true is like there's not a dynamic function naming thing here. So if I want to do log base 3, like this is probably not going to work, right? So there's log base 2 because that gets used a lot. There's log base 10 because that gets used a lot. And then really the way that we want to think about it as being the primary log or the main log we want to think about as being the natural log, and so we get something like this. Okay, so I Googled Tamu math module. So, sorry, Tamu, not Tamu, what the heck? Python math library. We get this. This gives us all of the different mathematical functions. I showed you log and sine. Obviously, there's going to be a cosine here. But here are some other things. So I'm going to look at. So it has them kind of categorized here. You can look at these over here. So power and logarithmic functions and so on and so forth. I'll let you look through all of these. Okay. So, and now I want to look at one here, kind of greatest common denominator, GCD here. So let's say I have a set of numbers, and I want to compute their GCD, their greatest common divisor. I said denominator, but I meant divisor. Math, okay, greatest common divisor. Let's look at 15 and, nope, 20. Okay, so the answer here should be 5. Okay, and so now here's an example of a function, the GCD function, that takes in 2 arguments, but could actually take in a number of arguments. So if I do 15, 20, and let's say 35, again, I should get 5. Okay, so here is a function that takes in an arbitrary number of arguments. It just has to be, each one of them has to be an integer. And if we want to go to the documentation to see that, so how do you read this? Okay, so math.gcd. Okay, so now this says star integers. So this just means it needs to be a list of integers. So whenever you see something like star integers, this is kind of an idiom from C programming language, basically. And it says we need a list of integers. So this says that the input to the GCD function is any list of integers, and this says what it returns, return the greatest common divisor. So let me let's go down to something like square root of x, or let's look at the logs. Okay, sorry, I'd never seen this before, and I just got a little. Okay, so math log x. This says it takes in an integer and gives out the base 2 logarithm. Log base 10 or log 10. Takes in an integer, gives out a number. Math power raises x to the power of y. So again, 2 arguments here. Now this is a little bit different than the GCD function. The GCD function says give an arbitrary list of integers. This says give exactly 2 numbers, an x and a y, and it raises x to the power of y. That's what, again. So I'm just trying to show you how to read this documentation. So if I want to go back to my notebook here. Oh boy, this is embarrassing. I have so many tabs open. So math dot power 2, 3. This should give me 8. Okay, and so on and so forth. Okay, so these are some basic math functions. I showed you the basics of it, but I also showed you how to find how to go to this list of math functions. And all of the different libraries and modules that we're going to look at will have a page like this, something like this, that will tell you the functions that are in the module, basically, and basically what it does. That is the number of things, the number of arguments the function takes, and exactly what the output is. And then other documentation like the type of error, the type of errors that it might raise. So this says raises type error if either of the arguments are not integers. So this is the number, so this is the in-choose k thing. So if you put in a non-integer for one of those, it's going to raise an error. So let me just illustrate that now. Math, so 5, 1, I should get 5 here, but if I do something like 5.5, this should give an error, okay? And the documentation that we just looked at says that is a type of error that we can expect, or that is the error that we can expect if we do this thing that it doesn't know how to handle. Okay, that's going to be it for this video. I had a list of things that I wanted to do for, and what I plan to do for the next video. Variables is what we're going to look at in the next video. In the next video, we're going to look at variables, and that'll be the last video for this week. Okay.